Hi, it's Paul from Heritage. I'm just going to do a little video about this call out that we came to and the problems this guy was having. I'm going to show you what the issue was with the call out and why we got the tripping circuits, and then also why for this particular bloke that this situation was dangerous. So that the way the distribution has been done in the house hasn't been done right. So then if we've got faults down the line at these sub-mains, so this is an outbuilding that I'm in at the minute. So I'm doing a condition report in here now due to the stuff that we found on the call out, and then also this has been done 10 years ago and no installation certs were given for it. Apparently it was just a bloke that the builder knew that did the electrical work here. So what I've seen so far is not good. It's on the condition report, so the work is quite poor anyway, and it's going to fail its condition report. But yeah, I'll just show you the thing that was tripping the RCD out in here, and then also in the house, which was taking half the house out, and why they've done it the way they've done it, and then the inconvenience that caused as well. So in here we've got the consumer unit, which is a budget range consumer unit. So lots of the screws are chewed up while I'm trying to do connections, tighten connections up. There was a cable that was damaged during installation here that goes out to the greenhouse. So the greenhouse supply goes out in a twin and earth, goes down into the ground, and then out into a double socket in the greenhouse, and it comes out the ground in the twin and earth, so it's not protected properly. To say it's buried in the ground, it should be an earthed armoured cable. So that cable's wrong. Anyway, we've got incorrect type of breakers used in the board, so they don't sit correctly in here. The earth bar isn't even attached to the board. It doesn't matter, it's not earth in the board, but it's just not good that that's flapping around like that. So I've got the power off at the minute, but one of these, the test buttons, isn't activating the RCD on one of them. So we've got failing RCDs. It's 10 years old. You got like holes in the board there, you can get your fingers through. You got incorrect cable used in the ground. And then it's incorrectly distributed as well. And then we've also doing some R1, R2 tests in the building, and there's a socket next to the sink there that's got no earth at it. And then we've got multiple of these sockets that I've got blue X's on have failed the R1, R2 test. So it's only 10 years old. They're very cheap socket plates, so we don't expect them to last more than 2 years anyway. From our experience, we've got an incorrectly bonded, unnecessarily bonded gas and water supply. So down there you can see there's a blue pipe coming in for the water, so it's plastic, and there's a yellow one coming in for the gas. So both of these services are coming in plastic because this is a fairly modern building. So there's a bonding cable going from here and bonding this pipe work at the incoming supply there, so that was unnecessarily bonded. So that kind of shows that this guy who did this doesn't really know what he's doing. He's just following like procedures for the standard type of job. So that's the kind of things like that are red flags for you know, giving us an idea of how qualified or how experienced the person was fitting the equipment. So when I got here, there was RCDs weren't tripping out in here. So this board, they weren't tripping out, but it was tripping out inside the house, and it was taking half of the house out with it. So we narrowed it down, did some insulation resistance tests, and narrowed it down to that FCU there next to the socket. Assuming that is connected to these external lights here, because he just says these haven't been working anyway, and none of these external lights in the soffit have been working. They've all failed as well. Again, just cheap gear. He had them like on a remote fob, so he could switch them on and off from the house, because there was no switching between the outbuilding and the house. So like cheap equipment, as in electronic controls, which have failed, and then also the light fittings as well have got moisture in, and and also have failed as well. So lots of reasons not to use crap equipment. So I just unscrewed this and lifted it off, and a load of soil came out. So I don't even know how that has got in there like that. That's insane. And it's as if someone's just took the top off it and just filled it with soil. I don't know how that's even there. So as you can see, we've got, this is a little like a relay thing that he uses to, with a little receiver on. So I'm gonna open this up, but I guarantee that's just only a little clip shut joint box. These are just going straight into holes, there's no stuffing glands on them or anything like that. So I disconnected that FCU inside there, and then we got the clear readings on the insulation resistance. So turned it back on, everything was fine. So it's going to be some of these outside lights, and the first thing I've done after lifting that off, this all fell out. This has been added on by somebody who wasn't an electrician, so straight away I'd say, right, okay, so they've probably not done it right. So I'm assuming this is the culprit, but that's part of the testing as well I've got to carry on with. So it's armoured cable into the outbuilding. There's a channel there that was dug out, and then apparently it goes underneath this garden here and over to the building over there. So we guarantee that isn't buried deep enough, and also won't have any warning tape on it, because the warning tape we use is at least 40 centimeters, 400 mil wide, I think, something like that. So that won't have any warning tape on it throughout its run. There's the armoured cable coming out at the ground, then it goes into a joint box there, and then it's twinning earth from there into the house, the consumer unit in the house. And then I'll just show you why it's behaving the way it's behaving. Right, so from that back corner over there, it comes into the house in twinning earth and is jointed onto a 16 mil. So it's a 10 mil supply over to the outbuilding, and then is jointed onto a 16 mil twin and earth into here. So what they've done is, this is a dual RCD consumer unit, so that RCD protects all these, and that RCD protects all these. So again, this is a super budget range consumer unit, which we say we don't recommend to fit. So he's put an RCBO, so this buzz bar is on, that entire buzz bar is on this RCD. So they've put an RCBO on the end, on an already RCD protected side of the board, and there's no discrimination between it. So this is a 30 milliamp RCBO on with a 30 milliamp RCD on the same bank as a 30 milliamp RCD, and then in the garage or the outbuilding it's also protected by 30 milliamp RCDs. So there's no like time delay stuff, RCDs, or difference in milliamps. There's no 100 milliamps on here, or there's no increased milliamps on here, just to prevent it tripping down the line, or particularly time delays or anything. So because they've done the wiring incorrectly, and if they'd have brought the armoured cable here, they could have put this on a high integrity, or its own board or something. But in here, there's no high integrity ways for you to be able to put non-RCD protected equipment in. So for starters, the board's not got the right ways on it for sub-mains. Normally you would have a sub-main non-RCD protected using an armoured cable. And then also, they've put an RCBO on to an already RCD protected side of the board, which is doing nothing. So what happened, there was a fault in the outbuilding. It's took this RCD out and that RCD out, which has took this entire bank of circuits out. There's sockets and lights on this circuit here. So that was, as it's not distributed properly, if this was an MCB inside the house on a non-RCD, on a high integrity connection or whatever, it wouldn't have disrupted the rest of these circuits in the house. It would have just took out the circuits in the consumer unit in the outbuilding. That's how it should be done to cause minimum disruption. But the way it's been done here, due to them not taking the armoured cable all the way to the board, they then had to cover this with an RCD anyway, because it's a twin and earth in the fabric of the building, which needs protecting then if this is buried in a wall. So if they brought the armoured cable out, that would be better. It could have gone on an MCB, and even if they brought the armoured cable out, it looks like they didn't know what they were doing anyway, because they've added an RCBO onto an RCD protected buzz bar. So it probably would have been the same outcome anyway. But if this was us, this would be an RCBO consumer unit, and then we'd be able to put a MCB in here just to cover the outbuilding. Or if it was a huge supply, it would have its own 80 amp, main cutout and fuse carrier and isolator. So that's why the distribution of this has cocked the rest of the house up. So in this situation, why this is dangerous for this particular situation is the gentleman's on a dialysis machine because of failed kidneys. So every day he is sat on a dialysis machine upstairs. He's got like a room that's like a clinical room upstairs with his own dialysis machine, and he's on that for 5 hours every day. And then the power cut happened. Now this could have been completely avoided if whoever had installed this had just done the job properly. That wouldn't have happened in the house, and then they wouldn't have the inconvenience of potentially RCDs tripping out because of faults in the greenhouse or faults in this building as well. So the greenhouse has got that, I told you, that twin and earth that just goes in the ground and back out the ground to a double socket. If anything happens out there, it affects in here, and it also affects in the house just now because of how it's been distributed. So I'm going to have to now, we're going to have to change cables up to the board, make it continue it as armoured cable to the board, put some sort of other consumer unit or enclosure on inside the house, so that can be a non-RCD protected circuit. We're going to change the consumer unit in here for an RCBO consumer unit, which we would have done anyway because this is this condition report's come back unsatisfactory. So we're going to do that anyway. That doesn't make it's still distributed incorrectly. So once we get all the problems sorted in this building, which is just with the problems with the installation that's been done, and he'll get a clean certificate. Well, get an installation certificate for the consumer unit we've done, and then he'll get once we've fixed all the problems on the condition report, I will then give him a satisfactory condition report, and he'll have his unsatisfactory condition report originally, then he'll have a satisfactory one to prove that work was found, advised it was done, we fixed it, now we've got a clean certificate to prove that we've done the work and everything is safe, and now his insurance will be covered. And then he'll have installation certificate for the consumer unit that we do, and then that'll be good for the next 5 to 10 years for his insurance. Whereas if you've had work done by somebody and they've not certified their work, you're knackered basically on from an insurance point of view, because if anything does happen, personal injury, damage to building, you need to claim on some form of insurance for that. They're going to ask for your maintenance. Have you maintained your building? And if you can't prove that, or if there was some certificates given, or you don't have any certificates like for the work that's been done, if the claim is over a certain amount of money, they're going to send somebody around to inspect it, to try and get out of paying out for whatever's happened. If it's a large amount of money, someone will be sent around to try and inspect and try and find out if the work's been done correctly, maintained, or any work's been done in between that's not been certified. It's what we find a lot. So in this case here, as he's had none of that, I'm doing the condition reports, doing the repairs, then you'll have a report that says it's safe now for the next 5 to 10 years, whatever we'll decide. and then also he's got an installation certificate for the consumer unit. For the house, that section of armoured cable where it's jointed, that needs continuing to the board. But what he was on about potentially having solar panels on this building anyway. And if he's got solar panels and battery storage in here, which is going to be feeding back to the house, we need to increase the size of the armoured cable anyway, because if his house is running on batteries that are stored in here, it needs a good sized armoured cable that can carry, you know, 80 amps maybe, or something like that. If he is drawing all the current from here through the batteries, through his inverters, to power his house or to power the garage where his electric car is going to be plugged in. So on the other side of the building, you've got a garage, small garage, which we've got to put a power supply to as well. So this is he doesn't want solar panels on his roof. He wants them on this roof. So we need to make sure that the cable, because he wants it also as a backup for if the power does ever go down, he can still run his dialysis machine and obviously use the power that he's generating from his solar panels, but it needs to come from this direction to the house. It's not on the house. So instead of faffing around with that cable and jointing it to take it to the board, so it's then we can then put it on an MCB, we're gonna just have to dig all this up, put a bigger cable in all the way to the consumer unit and attach it straight onto the main supply with like I say, an 80 or 100 amp cartridge fuse, switch fuse, 100 amp fuse, 100 amp isolator, and then no matter what juice it's pulling here or it's sending back down, that cable is capable of carrying that current. So there's a lot of work that we've got to do here to put it right and make it safe, but also any upgrades that he wants to do. And if they'd have just, when they did this building, put a decent sized cable in the start, we wouldn't have to be doing all this, digging all this up to increase cable size. So it's always better to spend a bit more money on a heavier gauge cable now, because in 10 years it might be useless. You may be digging it up and putting another one in. Right, so this is the repairing the bollards that I came to, that were tripping out, sorry, the electrics at this call out that we came to. So we're just going to be, that's the one I've taken off. So far I'm working my way through all 4 of them, correcting some issues. So this is the underneath of the fitting now. There was soil and moisture inside there, inside the fitting, and then you've got this is the manufacturer's joint box that comes with it. You know, so it's meant for just a flex going in and a flex going out. So you've got 2 armoured cables cut off here without the earth sheath linked, so that means these armoured cables buried in the ground are protected. The earth, the mechanical protection isn't earth, which it should be. So I've got to clean all this soil out. There's not a lot of room there to get some glands on, so I need to try and get some glands on them, go into a whisker box and then joint these properly, gland the earths up, joint the glands so that they're continuous into a whisker box, and then out of the whisker box with stuffing glands to the light fitting. So if this had have had a joint under the floor and these armoured cables were jointed properly under the ground and then a single cable was coming up here, this joint box probably would have been suitable, but they're not designed for 2 armoured cables going in and out of it. Again, it's tiny. So it's just been used incorrectly. Just because that's the manufacturer's box that comes with these light fittings does not mean that that box is suitable for every situation, and you need to change it accordingly. So I'm just going to clear all this out and redo all these connections, and then I've got another 3 to do as well. And then once we've done them, we can test them, insulate, you know, IR, test it, because this is the thing that was coming back with a dead short on it. So cleared it all out now. There was just enough room. I mean, they're actually sunk into that enclosure, so that was very difficult to get on. But there's just enough space for me to strip a bit of armoured cable back and get these glands on. So I'm going to put this into a whisker box now, and then that'll fit inside that. It's nice and clean out. You know, there's a fixing missing there as well, so I'm going to put another fixing in that. But then these are the cables are watertight where the steel. Right, so I've done all these now. So they're all made off, earthed, connections continuous, way goes. So what we established was with the customer before that this must be, there was loads of ants in here and worms and all sorts of stuff, so it must just be insects bringing soil up. It was a lot of soil though. It's difficult to believe that's how it was done, but it seems like things were coming up. So there's a couple that we had a few through roots coming up as well, a few plants growing inside, so it's probably something to do with that. So I've ordered some resin that you use to do joints under the ground, 2-pack resin, and then I'm going to resin all this base here inside right up to the bottom of these nuts, so no moisture is going to ever get in here, nothing's going to grow up through here, you know, so it'll be nice and dry inside the enclosure then. So I'm going to do that now they're all cleaned up. So we had the external lighting here that was faulty, the Bollard lights out there, which had, you know, what the cables weren't made up on the other video we did, weren't made up properly. There's soil in it, moisture in them and everything like that, and then it came back to here, and this is where it's supplied from. So you can see the armoured cable comes in there, just no grommet in the back box, no gland on that to earth the sheath, and then it goes up into the up there for another hole with no grommet, and it looks like there's a patch on the wall here, there's a joint buried in this, which I'm going to have to cut that out tomorrow because we're going to add this onto a smart system anyway and fit a Lutron module in here. But yeah, so you got no grommets in any of these in the boxes in here, no grommets in anything there. You got a spur to this FCU here, which is doing, with the cable there not doing anything, so I don't know what that is. This is going to the outside lighting. It looks like it, yeah, it comes through there, up in that twin and earth, and then the armoured cable goes up there, and then that's jointed, potentially in the wall there. It looks like that's one leg of the ring there. There was one leg of the ring there that's been cut off. So I'm assuming that's been damaged, and then he rerouted another cable, you know, when they were installing it, and rerouted another cable into the cavity. But yeah, that's just a right mess that. Oh, the socket plate's got to go back on this. It's only a 25mm box, so they're not deep boxes anyway. We always put 35s on. So you got a 25mm box, which is very tight anyway with cables. Then you've got all this crap in the back. So very poor installation. Most of these sockets failed the R1, R2, so these are 10-year-old sockets. So I've replaced all these now. Just going around replacing them all, new click ones. So here's my solution to the problem. I've done this because it was convenient to do this, because I had a module to fit as well for a smart module, a Lutron module, and we're going to be putting the external bollards on a switch from one of these, so we can set them on dusk till dawn, or he's got a switch at both ends then. So at the minute he's got no switch here or no switch in the house for the external lighting, and the switch was on an FCU there. So if he ever needs to come from the house in the dark, there's no way of switching them on. So that's that's why we've added this onto the Lutron system. So that's why I've done this box anyway. So where the double sockets were and the FCU, there was the cables coming through from the ring there. Then there's a cable coming through for the armoured cable there for the outside lights. Then there's the other leg of the ring coming in there, and then there was a cable here that was connected into the FCU, which doesn't appear to do anything. So I've just left that coil up in there. So we've sunk that in the wall just so the box isn't sticking out as much. I've put an FCU back inside it, so we're able to isolate the Lutron module with a double pole isolator. Plus we've took a spur off the ring, so we need to fuse it down to, like, you know, 10 amps, 6 amps, whatever. So I'll put like 5 amp fuse in there, which then protects the cable, which is supply the 1.5mm cable, which is supplying the Lutron module. And then back out the Lutron module, the armoured cable is connected straight into it and goes back outside, switches the external lighting. And then what I've done is, because we've obviously lost that socket and FCU there, I've just cut him a new socket in below the box and just took one single cable into here and wagoed all these together. So I'm just doing the consumer unit upgrade here now at this job. Just there's a few things here. I don't really know why this guy has done what he's done, so just showing you some kind of unnecessary work really that's been done. Again, I think he's got a misunderstanding of what needs to be done. So, local isolation, boilers there, consumer units there. An MCB or an RCBO qualifies as isolation. You can use that as an isolator. So unless you need double pole isolation of this boiler, that is the only benefit of having that there. It's local to it, so there's no need to be putting an extra joint for an FCU, then to go from there to there. You know, we might as well just go straight from there on its own circuit, and then the isolator in the board qualifies as for local isolation, as acceptable isolation. So what he's done is he's wired a radial circuit out of the MCB and then in and out, in and out, in and out, in and out of every one of these, and then end of the line. So he's took a 16 amp circuit, one 16 amp circuit out, and supplied 5 FCUs. This one that says spare on there, I'm not sure what that is. But we've got the electric blinds in here, far socket, mid socket, near socket. So unless this guy has specified he wants some form of double pole or some sort of isolation, there is absolutely no reason to put these here. So if anything, he's restricted the ampage that the socket can take. So you've got your radial circuit, which is a 16 amp anyway, supplying all these, and then you've got a 13 amp fuse in each one of these. So the socket could only pull 13 amps, and then it would start blowing this the fuses in here and these fuse carriers. So I don't understand why. I mean, again, maybe just to save cost on a consumer unit, so he's got less circuits to put in. But again, if it was me, there's no need to put all these sockets on individual circuits anyway. You could have done them all on one radial, no problem. That would have been one RCBO, and that would have just been floor sockets, and then blinds could have been on another one. So I'm going to take these out of here, and then I'm going to add more RCBOs in the board and put each one on its own circuit, so it's not restricted. Then I'll put it on a 20 amp breaker then, so it's got more capacity. That you can pull from the socket. It's not bottlenecked by these. Again, it serves no purpose apart from some form of double pole isolation. That is it. So that's it. Change now. So previously the armoured cable wasn't glanded with a banjo because it was a plastic consumer unit, so it was just attached to the PVC board but wasn't earthed. So the steel wire for this supply cable wasn't earthed as well. So now it is, because it's bonded to a metal consumer unit. We brought that 10mm in, got rid of all them FCUs that were here, tidied it all up a lot neater now. Just moved the supply over there for the boiler. So even though I needed some extra ways in here, I've still got 5 available ways there at the end. So it's always better to put a bit of a bigger consumer unit on. So we've got surge protection on the front there. Obviously all these are RCBOs. And then this surge comes with a little buzz bar on it that connects to the front screw, so that's really good. So they're all torqued up, nice and neat, everything tight, all RCBOs now. So this is the start of sorting his distribution problems out that he's got. So at least if anything in here now goes, it only takes the one circuit out. But still, on the other end of this, we've got a a cable going to an RCBO, which is on an RCD protected bus bar. So if anything does go wrong in here, it still takes out the house. And that's the next bit of the process that I'm going to be sorting out. So we're just getting this building at pass and certified, because at the minute it's got no installation certificates, no condition reports, no anything. So if anything was to go wrong, his insurance would be void if it was to do with the electrical installation, anything that went wrong. Whereas now we'll give him, I've got his condition report, the original condition report with all the faults on, a new clean satisfactory condition report with all the faults cleared, and then an installation certificate for this consumer unit, and then a Part P certificate for this consumer unit as well. So he's now covered for the next 5 to 10 years on this building.